Okay, so in this, I'm going to discuss something related to data warehouse. So relating to dimensions. So how are these dimensions are classified? So these dimensions are classified into seven or eight different types. So now we are going to discuss what are those eight different types. So slowly changing dimensions. So we need to understand about how the dimensions are. So this is not related to Tableau. So this is something which is related to data warehousing and databases basically. So we just need to have some knowledge on the SQL side and as well as data warehouse. So that's why I'm giving you some brief about these things. So now we'll discuss about first type is slowly changing dimension. So in the name itself, it is mentioned that slowly changing. So that means this type of dimension will change slowly. So sometimes in our data, in SQL or Oracle or in data warehouse, what happens is, so you will have a customer ID, customer name, and you will have the address of that particular customer. So after some days or after some years, so what happens is they might have changed their address. So what will happen? They will re-enter the data in the system. So you will see two records. So this ABC customer was in city Rochester and he shifted to Albany. Okay, so this type of things will be stored in slowly changing dimension. So basically, so this will keep on changing. So whenever he shifts to one place to other place, so these type of dimensions are called as. So in this case, city is called as a dimension which is a slowly changing. So they might change for years. Like whenever you put some address in the system, so in that particular place you might stay for some years. After some years only you will change that dimension. That is the reason we call this dimension as a slowly changing dimension. So in this also, so while storing this particular data in the databases, so we use different types. So now we'll discuss about type 0. So this is called as passive method. So in this type of records which were inserted will not change anytime. So in type 0, whatever you enter, so this no one will touch those records and this will not change at all. So that is about type 0 where it is like permanent data. Like if you enter something, so that is like you can't change those data records. So that will be like permanent. And now let's see type 1. So this method overrides the old record with new values without tracking any historical data. So let's say this person, ABC customer, has moved from Rochester to city Albany. So this will remove the existing records from the database and it will put city Albany. So we will not have any historical records saying this person has stayed, what is the city name? This person had stayed previously. So we will not have that particular information. So that is about type 1 slowly changing dimension. So that is about type 1. And now we'll see about type 2. So basically this method tracks the historical data by using version number or start date and end date. So earlier in type 1 what we had, so we can see the updated data. So whatever is the current updated information which is available. So the customer has moved from Rochester to Albany. So we will have the latest data where the person is exactly. And if you go to the type 2, so this method tracks the historical data by using version number. So it will maintain history by using version numbers. So let's say 1, 2, 3, 4. It's the same example basically. So ABC customer. So he stayed in Rochester. So the version is 0. And 1, 2, 3, 4 ABC customer. He moved to Rochester to Albany. So the version says it is 1. So depending on the higher value, we can assume that this is the latest value. So if you get a new record, and he moved to some other place from Albany to some New York or a different city. So you can see that particular record and also the previous records. So in type 2 slowly changing dimensions, we will have the records based on the version number. And there is also one more type where we can store the records. That is, we can mention the dates. So in the database or in the data warehouse, we will mention the start date and the end date. So this particular person, he made an entry in 7th July 2013 till 21st December 2015. He is in Rochester, and in 22nd December 2015, he made a new entry saying he has moved from Rochester to Albany, and end date is null, meaning he is currently staying over there. So basically, we will be able to track all the previous records. So where the person is, like when he made an entry for the first time, so where he was and currently where he is staying. So all those details will be stored in the type 2. In type 2, it will store the historical in two ways, which is version wise, and by using start date and end date. Okay, so by using start date and end date, we can maintain the history. Now we'll discuss about type 3. Okay, so earlier we were maintaining, so in type 2, we were maintaining some extra records, some extra based on the extra records by using start date and end date, or by using version number, we are maintaining. But in this method, we will track the historical data by inserting the column, by inserting a new value to the column. So here you will not see any new rows. So old city is my, so the person ABC customer moved from Rochester to Albany. So you can see the previous uh, dimension or previous value you can see in the different column, which is says old underscore city. So here you can track the historical information by adding one more new column. So type 3 is based on the new column. Type 2 is based on the new row. So it is adding new row. So whenever there is a new entry, it will add new entry, and the previous entry, it will mark as a older version, or you can see the start date and end date as well. So that is about type 3. So type 3, it preserves only limited history. So it can't keep on adding the columns. Like say you have some 10 new records which got added. So it can't keep on adding the columns. So it basically preserves a limited history. So that is about type 3. And now we'll see type 4. So this method uses a separate table for storing all the historical data, and main table will hold the current data. So whatever data which is there, so all the records will be stored in the history table. So if you have customer table, so there will be a customer history table. All the data will be stored in this. So whenever there is a new entry for same customer, so all the entries for that particular customer will be shown in the history table. So Rochester was his old record, which is created in 22nd December 2015, and Albany is the new record. So that way you can see this records getting updated. And if you see, so in customer table, you can see only the latest information. So everybody needs only the latest information. But when you want to track, so then you can also check in the history table as well. So that is about, so this is like maintaining the historical data in the database and in the data warehouses. And we also have type 5, which is called hybrid method, and which comprises of type 1 plus type 2 plus type 3. So basically, it is a combination of all this type 3 and type 2 and type 1. So basically, it combines all these three, and it uses flag values flag values in the sense we have seen the version numbers. So by using flag values, we can identify which is the latest value and which is the historical values. And we also have effective date to differ between old and new records. So you will also see the effective date. So when it was entered and all. So all those information we can see. So all these 5 types. So in slowly changing dimensions only, we have 5 different types of storage. Okay. So in the type 1, we are just storing the latest records. Latest records. So there will be no historical information. There will be no historical. There is no tracking of historical data. Historical data. Type 2. Okay, so here we can track historical data. Historical data by version number or by start date and end date. Basically, it will keep on adding the records. So whenever there is a new entry for the same customer, so it will keep on adding records. So that's about type 2. And now we'll see type 3. So type 3 is basically limited information. It will store limited historical information. Okay, so keep on adding. Basically, it will add rows. This type 2 will add rows. And limited historical information for type 3, it will add columns. Okay, so to differ the old values and new values, it will add columns. So if you see in the type 3, so there is a old underscore city column which has got added. So to track, it will add to track, it will add columns, and there we can see which is the old value and which is the new value. So current city, so basically city will be updated as latest value, and the old city you can see the next column. So type 3 is basically will create a new column, and based on that we can see which is the latest value. And type 4, okay, so type 4 maintains a separate table for history, and one more table, customer table or main table, will be with the latest data. So here you see, so we have customer information and customer history. So it is about the same customer, but in history table, it will keep on updating with the whatever entry made by this particular customer name ABC. So all these records will be entered here. Even if you move from Albany, so first of all, he started from Rochester and he moved to Albany, which is the latest record. Okay, let's say he moved from Albany to New York. So there will be one more third record will be added here over here. And in this, you can see the latest record, which is New York. So that way, every time this customer table or main table will be updated with the latest records. And in history table, you can see all the entries. That's about type of 4. And now we'll see type 5. So basically, it's a combination of type 1 plus 2 plus 3. So in type 1, we have latest records. So this can be a combination. So that means it can track historical data by keep on adding the rows, or it's by adding the columns as well. and also this will have flag values and effective date. So in this it will have flag values and effective date. Flag values and effective date. So it's a combination of type 1 and type 2 plus type 3. Okay, so now that we have discussed about slowly changing dimensions, now we'll see rapidly changing dimensions. Okay, so why do we call normally this slowly changing dimension? Because so it is changing yearly once, or like it won't change that easily. So moving from one place to other place, it's like it will take some time. So that's why we call these as slowly changing dimension. And there are some dimensions which are rapidly changing, like weight. So a person weight will change day to day, or for 1 week it will change. Even the blood pressure. So if you see blood pressure in the morning, when the next day you can, if you check the blood pressure, it will be different. So for that, if you need to maintain the data, so for every day, if you try to maintain a record for that, so that will be huge lot of data. So it's better you maintain a table like type 4. So in type 4, what we have done is we are maintaining the historical information in one table, and latest information we are maintaining in the main table. So in that way, we need to maintain like type 4 dimension we need to maintain. Why? Because it's rapidly changing dimension. So every time you need to keep on changing the data. Let's say here you see for Anna, same person has different weights, has different blood pressures in a week or in 2 weeks of time. So there is a lot of change that you see. So every time you can't keep on adding for each and every patient or each and every person. If you keep on adding, the number of records will be more, and it will be very tough to handle that particular data. So what we do is we maintain a historical table, and in the main table you will have only the latest record. So whatever is the current record, so you'll just check the updated date, and we will take only one record into the consideration. Even you want to know the person's weight and blood pressure, so you would want to know like what is the current status of that particular patient. So that is about rapidly changing dimensions. And now we are going to discuss about junk dimensions. So junk dimensions are basically uses flag values. So let's say gender and marital status. So basically these are two dimensions, which is gender and status. Okay, so instead of using two different tables to get this information, what we can do is we can make a combination by doing a cross join or something. So we can make a combination and do a join. So instead of using two different tables, or instead of using two different columns, we can use one column or one table while combining this. So if we do a cross join, what happens? So there are three in this marital status, and in gender you have two. So basically, so if you do 3 into 2, so you'll get 6 records. So 6 combinations you get. So then you can use this one table instead of using two different tables. So we can make use of one table. So basically these are called as junk dimensions. So we can convert into usefully like by making into one column. So we can use one single table for this, so that in fact table, no need to have multiple columns to store the primary key values of this flag. So every time you don't need to join with gender and marital status separately. So if you combine it together, so if you want to combine, you need to have all the combinations. So in male also we'll have married, single and diverse. In female also you will have married, single and diverse. So you need to have all the combinations. For that, what you need to do is a cross join. So then you will get 3 into 2, which is a combination. So these are the possible combinations which will be there. So 3 into 2, which is 6. So that's why you can see in gender, marital status, you can see all the set of combinations. So that is about junk dimensions. Okay, so info dimensions is basically, so whenever you enter into an organization, Because on that particular day when you join, you might not have your ID created. So employee ID. So there will be some IDs will be there like this. Okay. Employee name. So like this, if you have your names, and as this person is newly joined, okay, so they might not have this ID created for this particular person. So uh, this block might be blank, or they might enter some random temporary number. Let's say temporary some number they might have entered. Okay. So basically what this info dimensions is, so dimension which is important to create a fact table, but it is not ready yet. So we can use some dummy details, or we can keep this as blank. Okay. So whenever this ID is created, so you can put that ID like this. So after getting the details, we can update the details in the dimension. So these are called as info dimensions. So info dimensions is nothing but you might have empty or null details or dummy details. So later you can update it based on the entry. So once this ID is created, you can make the entries. So there are certain columns like employee ID. You might not have employee ID created for some new joiners. So that can be a blank, or some temporary ID might be created. So once the new ID is generated, then we can put in the new ID details over there. So this column is called as a info dimension. So this type of columns are called as info dimensions. And we also have conform dimensions, which are connected with multiple fact tables. Okay, uh, so let's say customer dimension and product dimension are required to connect to different fact tables like shipment fact or sales fact and service request fact. So if a dimension is connecting to multiple fact tables, then it is called as conformed dimension. So degenerate dimensions. A degenerate table does not have its own dimension table. So basically this will have, so degenerate dimension table does not have its own dimension. Basically it comes with the fact table. In fact table, whatever is the dimension is available, like invoice number, in the detail like product ID. So whatever is the column that is available, so that is called as a degenerate dimensions. And we also have role playing dimensions. So same date column can be used as a date of sale or date of hire. So based on the situation, uh, based on the sale type, so we can use the same date dimension as a date of sale or date of hire. So that way, so whichever dimension can be used in different ways. So those dimensions can be called as role playing dimensions. And the eighth dimension is shrunken dimension. So if we go to our Tableau, so if you take an order date, so basically it comes up with an year, and you can use this as a quarter, and you can also use it as a month, and you can also use it as a day. So basically you can use it in multiple ways where you can shrunken the data. So from year to quarter, quarter to month, month to day, and you can convert that particular type. So where you can shrunken the data. So in this case, you can say date dimension is the one where you can use it as a shrunken dimension. So what will be the shrunken? So if in a week, the shrunken dimension for the month. So day is the shrunken dimension for month. Month is shrunken dimension for quarter and year. And now we'll see about static dimension. So as the name mentions, this do not change with time. Okay, so there are some specific dimensions which do not change with time. So let's say we have seen slowly changing dimensions which can change with time. Why? Because a place is entered by the user and he shifted from one place to other place. So then there will be a change in the data or change in the dimension. And so you will change the address of that particular person. And in case of, let's take an example of birth date. Okay, if a person enters his birth date, then there will be no change with the time. So even if you see after 100 years, the birth date of that particular person will be as it is. So there will be no change, or he cannot change that birth rate. So that those are the dimensions which will be static and which will not change with the time. So these are the 9 types of dimensions. So uh, how it will be in data warehouse? Any questions? Okay, so that's all related about data warehouse things. So it might not be related to Tableau, but it's good to have this knowledge on how this dimensions and slowly changing dimensions. So you might get some questions like what is slowly changing dimensions and what are the types that are available in Tableau. So I mean, so what is the fact table in that? So mhm. Okay, okay. Yeah, so I'll no problem. So basically, whenever you have facts in that, mostly if you have so these type of facts, let's say profit, sales, discount, these type of facts, and you let's say you have some primary keys. So you should also have dimensions in this fact tables. So when you have most of the fact values and some primary key related informations, so then you are connecting it to different dimensions. So trying to, let's say, in your case, you are trying to get survey information and the I mean, in survey, you're trying to get what is the rating that is given by patients, right? So, so the ratings will be are the basically those are facts. So the rating wherever you see these ratings in a table, so that table is called as fact table. So any other information which you are grabbing from other tables, so those are basically your dimension tables. So whatever so survey details you have and you have the patient name. So and if you have some hospital. Hello, am I audible? Okay. Yeah. So basically, in your case, it is like whenever you have ratings, so If you see ratings in your data, that means that's a fact table. And in that table also, you will have some dimension columns. And if you are trying to get some other columns also into the into your fact table, so that is where you will get this data modeling. Okay. Yeah, correct. Yeah, correct. Yeah. Okay, so that's about this dimensions and all. So we'll see about some Tableau questions now. So I'll just tell you about some functions which are there in Tableau, which are very important. So if null, is null, and zn. So these are some uh, functions which are related to nulls in our data. Nulls in our data. So let me create an Excel file. Some region, or let me take subcategory. So I'll copy paste this data and I'll put some nulls in the data. Yeah, so this is the data which I have for region and subcategories. And let me remove some values here. Okay, it is given articles. Or let me enter some random data. Okay, so I'll remove some data, save this file. About nulls. Okay, so now I'll take region, subcategory, and sales. So you see there are some nulls in the data. Okay, so if I use Zn function, so if I use Zn function of sum of sales, so instead of nulls, I will see some number. Say okay, which is 0. So I can see 0. So why it is important is, so let's say if I want to add for sum of sales, let's say if I want to add number 2. Okay, let's say some addition I need to do for this. So addition of 2. So I got a requirement to add some $2 of sales. So I'm adding this, and I'll put this in the calculation. So yeah, so you can see $2 being added to the normal sales. So I have $8 and I can see $10. Wherever it is $2, $4, $5, $7. So I can see that. And if you see for null, it is not adding anything. Why it is not adding anything? Basically, so if you add, I mean, any mathematical calculation will not work if you have nulls in your data. So even if it is null, so I want to add, I'm adding $2 for each and every sale value. So I want, if it is null, that means I want to see the $2 at least. So I'm not able to see this $2 because I have nulls in my data. So then I can't do any mathematical calculation. So if you use Zn function, so I'll make a duplicate of this one. So I'll add Zn addition of 2. So now I will add plus 2. Okay, so now I am doing Zn and I'm doing plus 2. So now in Zn what happens? I can see 0. So 0 plus 2, you will have some value, which is 2. Say okay. Yeah. So for this, you make use of Zn function so that you can convert null to 0. To convert null to 0. So that you can use mathematical calculation. And now we'll see is null. Is null. Is null of sum of sales. Okay, so is null meaning it will show if it is null or not. So if it is null, it will show true. If it is not null, it will show false. So I'll put this in the next to sales. Okay, so in these two cases, it is null. So to check whether it is null or not, so we can use this function, is null function. Or we can write some calculation. So to check whether the column has nulls or not. Whether the column has nulls or not. And we can make use of this is null in calculation. If is null of sum of sales equal to true, then let's say 2. Else sum of sales. Okay, so what I'm trying to do is, in case of Zn, what happens? Null will be replaced with 0. So in this case, I'm telling Tableau to, instead of if this sum of sales is null, so show 2. So I'm writing that condition, new is null condition. Say okay. Okay, now you can see 2 as a value. So not only 2, you can use any number that you say okay. So where is this? Yeah, here it is. So this last column. So whenever it is not null, it is showing the actual value. Whatever is the sales value, it is showing. And whenever it is null, I'm replacing it with a number which is 5. So like this, or you can enter 0 as well. So whenever it is null, you can put 0. So instead of using this thing, you can use ZN function only. Anyways, if it is null, it will just give you 0. So this way also we can make use of isNull function. So what it does is it will check for whether the value is null or not. So it will check the value is null or not. Based on that, we can write some conditions like this. Say okay. Now we'll see about if null. And we can write something directly. So is null is to find out whether it is null or not. Here we can directly write what if it is null, what we wanted to do. So we can write here itself. So I have written some calculation. So whenever it is null, I wanted to see some value, which is 5 or 2 or 3. So I have written some lengthy calculation where I have mentioned if is null of sum of sales equal to true, then show some value, else show the normal sum of sales. Here I don't need to write such things. I can just say if null sum of sales, let's say I want to enter 99 for sake of discussion. So this is about if null and say okay and use this. Okay, whenever this particular sales value is null, in those cases only it is showing as 99. Apart from that, it will show normal value only. Normal sales value you can see. And we can also put, let's try some dimensions. So let me remove central here. Save this file and refresh this file. Okay, so there is a null in data. And if null, okay. So whenever there is a null, so let's say I want to enter other. So you can make use of this if null function for the dimensions as well. Uh, Complete region you can say. Say okay. Complete region next is. So whenever there is a null, I want to replace that null with other. So this way I can identify, and I can also use is null of region. Okay, so what it will do is it will check the entire region column and it will see whether there are any nulls in the data. So I'll put this next to the region column. Okay, so there is one null. So there it will show true, and wherever it is not null, it will show false. So this is null is to find out this particular thing. So Zn we can use only for measures. So Zn only for measures. And if null and is null is for dimension and measures. dimension and measures. Okay. Any questions on these three functions? Okay. Okay. So in Tableau, not only we can drag and drop the values, so we can just type in. So let's say customer name, you don't need to drag it and put it here. You can just double click on this and you can see that. Otherwise, you can just type in here and put customer name, or you can write any calculations here itself. Let's say if you want to do sum of sales or sum of profit divided by sum of sales. So you can do then and there itself. So here you can see the percentage. So this calculation is called as on the fly calculations. So this will not store this particular value. And I want to show this in percentages. So I'll just right click on this, click on format and make it as percentage. So in numbers, you can convert into currency standard and normal number standard and percentage. And decimal places we can specify and say okay. And if you put any number of columns, so it will do the sum of profit divided by sales according to the each and every customer. So whatever is the sum of profit for Aaron Bergman, and it will in the denominator it will take the Aaron Bergman's sales as well, and it will do the calculation. And I'll also type in this sum of sales. Sum of profit. So whenever I create any measures on the row shelf or on the column shelf, I will get the axis like this. And for each axis, you will have one marks card. For sales, I have a marks card, and for profit, I will have a marks card. So let me. So this is about sales and this is about profit. Yeah. So for profit, you can see one axis. For sales, you can see one axis. So if you want to make changes for this axis, so you can just click on this marks card and you can make changes. Let's say if you want to color each and every customer name in with a different color. So put customer name in the color marks card only for sum of sales. So this marks is related to this axis. So put customer name in this color box. Okay, each and every customer name will be colored with a different color. And when you hover on this, you can see the tooltip. So you can show whatever the information that you want to show in the tooltip. And let's say label. So label, I want to show the sales value. Put it in the label. So you can see the label on top of this bar. In profit, I want to see profit value. Yeah. So you can see different types of modifications that you can do for each and every measure by using these marks cards. So you can see different marks card for different measures. And you can keep on adding measures like this. So you will get one more axis related to discount and you will get one more marks card for discount as well. And you want to show discount value on the label. So put it on the label. So that way you can see. So that is about this normal type in function. So we just discussed about how to type in. In type in, we can just write the calculations as it is. So whatever calculation I have written in the calculation, so I have clicked on this and I have written that calculations. So instead of that, you can just copy paste copy paste these things in the row shelf and column shelf directly. Okay, so you can see those calculations getting created. So it will also give you the same output, but the only thing is you will not see the names. So if you type in here, you will not see the exact names. In calculations, the advantage is if you create something, so that will look like a column. So whatever calculation that we are creating, that will look like a column in the database. I mean, so Tableau will create a column. So whatever calculation that I have written, basically what are the columns that I have taken? Only 3 columns that are coming from the database. Apart from 3 columns, I have created many columns. If null, I have created new is null, sales, ZN addition of 2. So these are all the new columns. So in Tableau, at most we can do is creating the columns. Creating the columns. So we can't change anything in the row level. We can only create the columns. In that columns, row level, we can do any type of calculations. Like if you want to add to, or if you want to use any mathematical operations, so within that column, we can do any particular operation based on the rows. But we can't increase the number of rows in the data. So we can't insert any rows by using Tableau. Any calculation if you use, you can't insert any number of rows in the data. The only thing we can do is the addition of columns. If you create any new calculations, that will create a new column. So the calculation to which is a Boolean function, T by F is called as a Boolean function to check whether whether the column is null or not. So this will check based on that. If you use is null function is so whichever function starts with is, so those are like checking functions. So these many functions are there. So all these functions to check whether the value is null or not, whether this particular name is exist or not. So all those things will be there based on the is. Okay. Any other questions from today's session? Am I audible? Okay. Narayan, can you tell me about if null function? Lakshmi, can you tell me about is null function? Okay. Meenakshi, can you tell about ZN function? Yeah, perfect. Yeah, Narayan, you were trying to say something? Okay. Can you tell me about if null function? Okay, no problem. So if null is basically whenever you have nulls in your data. So if you want to replace it with other number or other things, let's say in this case, so central, the regions are all central, and there is a null in the region column. I have replaced it with the other column. Yeah. So in measures also, if you have nulls, so I have replaced it with 99. So in that way, if you want to replace, so you can use if null function. Okay. So that's about today's session. So if you don't have any questions, we'll wrap the session. Okay, thank you all for joining. We'll continue tomorrow. Yeah, yeah, please. Okay. Okay. Mhm. No, okay. So as per your requirement, what I understand is you can do it with Tableau desktop only. So action filters you need to use. So if you have the data, so do you have everything in one database, or you have everything in one table? Okay. If you have everything in one Excel sheet, then it's you can do it in Tableau desktop itself. No need of Tableau prep there. So Tableau prep is to prepare the data. So if you have the data prepared already, so no need of Tableau prep. So you can use that same thing and you can use action filters. So I'll just show you one example. Let's say in your case, you have two different types of one is children and you have adult hospital and all. So let's say we'll take Canada and United States here, and in others I'll take state. In other sheet I have state. So basically what you're trying to do is this is about children and this is about normal hospital. So when you click on normal hospitals, you want to see the list of normal hospitals. And when you click on children hospital, you want to see the list of children hospital, right? So here you can use actions, worksheet actions. So add action, filter action now you apply and select. So in sheet 5, I mean, you create these two sheets, sheet 5 and sheet 6. So make the sheet 5 as your source and sheet 6 as your target sheet and select this select button and show all values. Say okay. Yeah. So when I click on Canada, yeah, two sheets. It will be, then you can drill down basically. So Canada, if I click, I can only see Canada related states. And when I go back and I select United States, I can see United States related states. So in the same way, in your data also, you will have like this. So when you click on normal hospital, you will see list of normal hospitals. And when you click on children hospital, you can see the children hospital. Yeah, so today morning session, I have discussed about action filters only. So maybe you can follow that video. So morning I have shared one link. Yeah, yes, yeah, I have showed a similar kind of. No. Okay. Okay. So in Tableau prep, what you can do is you can prepare like flows. Mm. If you have Tableau prep access, you can do that with Tableau prep also. But I don't have much idea about Tableau prep. Yes, in Tableau prep, you can do all the transformations. Like we do it in SQL and Oracle, right? So we can do all the transformations in Tableau prep. Even you can do pivot and pivot. You can put join conditions, unions. You can do most of the transformations. Excel also there is an option called pivot, but I don't know how that works. Yeah, we'll try to connect. Maybe not in these sessions, but later we'll connect. Oh, okay, yeah, sure. Okay, sure. Send me that sample data and we'll look into it. Okay, so that's all for today's session. We'll continue tomorrow. Thank you all for joining.